Today we are going to explore the differences in vowel quality between children and adults of different genders in Mandarin Chinese. I believe that most of us can clearly distinguish the voices of children and adults as well as males and females because they're so different. So, what makes their voice quality so distinguishable? Is it caused by their different sizes of organs? Obviously, the organs in children are all many versions of adults. Then, what about men and women? Newborns' vocal tract is about 6 to 8 centimeters, while females and males are respectively about 15 and 18 centimeters. The former frequencies change depending on the length of the vocal tract. The longer the vocal tract, the lower the formant frequency. And also, Peterson and Barney's research shows that varying groups of people have different mean formant frequency for the same vowel, with males having the lowest, followed by females and children having the highest, apart from age and gender differences. Even if a vowel is shared by different languages, there will be differences in vowel space. Chen and his colleagues examined the difference in vowel space between three shared vowels produced by adults and children in Cantonese, American English, Greek, Japanese, and Korean, finding that the vowel spaces in English and Japanese differ in size and shape from those in Cantonese, and the production patterns of 2-year-olds have more variation than those of 5-year-olds and adults. Because most previous study on children's vowel space has focused on native English speakers, such study on cross-linguistic vowel space differences led us to consider how the vowel development of native Chinese speaker is like. Yang and Fox's research on vowel production development in Chinese-speaking children reveals that, in terms of vowel duration, vowel space, formant dynamic, and other acoustic parameters, all 5 Mandarin vowels produced by children differ from the adults. Chen and her colleagues' longitudinal study on changes in formant values and vowel space through time in 2 Mandarin-speaking children under the age of 9 give us a lot of information. They find a continuous decline in formant value in the boy during this period, while the girl did not notice a downward trend until age 9. And in addition, a significant downward trend in fundamental frequency was observed in boys between ages 8 and 9. The trend of contraction in the F1, F2 vowel area continued from 7 to 8 in the boy, but not in the girl. This evidence shows that even in childhood, gender differences can lead to differences in vowel quality. Why do all the studies I mentioned earlier tend to study vowels? That is probably because compared with consonants, it is easier to acquire vowels, and children begin acquiring vowels at a very early age. So now let's consider children's vowel acquisition. At 3 years of age, children accurately produce over 90% of vowels and diphthongs in words. So, in this study, I tend to select children older than 3 years old. What's more, children master the vowel u, o, i, earlier, whilst the vowels e were produced with the least precision. We, therefore, predict that vowels that are earlier acquired will show greater similarity to the adult norm. Next part, I'm going to introduce the methodology. Firstly, for the participants, There will be 4 groups: 15 3 to 6 years old boy, 15 3 to 6 years old girls, 15 25 to 30 years old males, and 15 25 to 30 years old females. They are all Chinese native speakers born and live in Beijing. Before talking about speech materials, we need to know some characteristics of vowels used in Mandarin Chinese. There are 10 monophones in Mandarin, but there are different vowel levels based on how the vowels are combined with other components in the rhyme scheme. We will focus on the first level vowels in Chinese. That is, the monophthong that can be combined with only one onset. There are 7 first-level vowels listed below. And if you want to see specific examples, you can refer to this chart, which lists the example of each first-level Mandarin vowel. But here, we only going to choose 5 of them. Delete the high front apical vowel and the high back apical vowel, because they are very similar to the E sound, but can only appear after alveolar and retroflex affricates or fricatives. We choose 10 basic Chinese disyllabic words that are easy for children to produce. 2 words for each vowel. They are mostly CV constructions, except for the word 羽毛, feather, which, due to the specificity of the vowel 语, can only occur along or after alveolar palatal fricatives. And all target monophthongs are located in the first syllable and have a specific meaning, ensuring that their pronunciation is not omitted. Most of the words are nouns or verbs and can easily be shown through the pictures and hints. For the procedure, the test is divided into 2 parts. In the first part, we're going to do the simulate test, namely a picture with a Chinese audio hint, prompt to guide them to say the correct word and familiarize them with the process. And in part 2, all subjects will then be shown with a random picture of the 10 words, accompanied by a short voice prompt. The whole process will be recorded for the next analysis. Next, we will analyze the fundamental frequency, the vowel duration, and vowel space. We have 2 independent variables, namely age and gender. In fundamental frequency analysis, I will analyze the average fundamental frequency of 10 target vowels for different age and gender groups, and then plot them in a box plot with the 4 groups on the x-axis and the fundamental frequency on the y-axis. In analysis of vowel duration, we will take the same approach to plotting box plots, but we will also perform a second analysis, which is to separately analyze the duration of the 5 vowels to see which vowel in average will take a longer duration time. So the x-axis becomes 5 vowels, while the y-axis remains vowel duration. But each vowel is represented by 4 box plots representing the average duration of the vowel produced by the different groups. Finally, for the vowel space analysis, I will plot 4 graphs, which represent 4 groups of vowel space, with F2 as the x-axis and F1 as the y-axis. Taking the vowel A as an example, 15 people produced the A sound 30 times, and these 30 A sounds will be represented in this diagram. I will circle the range and mark the central point. representing the distribution of the vowel R. After plotting the four charts, I will look at whether there are any significant differences in the distribution of the four groups of vowels. I will also compare the position of the vowels of children and adults to see which sounds are closer to the adult norm and which one differs significantly. We can assume that for the children, the vowel that is closer to the adult norm is acquired earlier. In addition, I will look at whether the distribution of these vowels is more concentrated or more widespread. If the vowel distribution is more widespread, then the group has a high degree of variability in pronunciation, and vice versa. Thank you for listening.